So here we are with some KSP samples and how they relate to pH. Now remember, KSP is its own format. For KSP, you always start with the solid and then work your way to the ions. So if you're talking about the KSP of silver hydroxide, then you are forced into the following equation. Solid silver hydroxide breaks into aqueous silver ions and aqueous hydroxide ions. And again, you do not have a choice in that matter, even though that we are in a Ka-Kb format. If they have given you KSP, this is the equation that you have to use here, right? So what we've got now is we've got that KSP is going to be equal to the silver times the hydroxide, and that has a value of 2 times 10 to the negative 8th over here, right? So I got an I, I got a C, and I got an E, and I don't care, and it didn't say anything about that. Please note that it did say saturated. Saturated, if you remember from before, is code for at equilibrium. So what's going to happen is this guy's going to go down by some amount X that we kind of don't care about unless we're looking for the solubility, which means each of these guys go up by X to be X and X. So you have X squared is equal to 2 times 10 to the negative 8th, or X is equal to the square root of that. So 2 times 10 to the negative 8th to the square root gets you 1.41 times 10 to the negative 4th. So that means this here is 141 times 10 to the negative 4th, and this here is 141 times 10 to the negative 4th. Now, what do either of these things have to do with the pH? Well, we now have the OH negative. And if you remember from before, that's one of our corners of our pH square. And if you know any one of your 4 corners, then you know all of your 4 corners. So my hydroxide is 141 times 10 to the negative 4th that's here. So I can either go around this way or around this way to get to the pH. I personally like to go the log route first. So that means my POH is going to be 385. That's here, which means my pH is going to be a 10.15. A 10.15 that's there. If you'd preferred to have gone around this way, it's not a problem. It's just that you have to use this equation here, that it's the H positive times the OH negative equals 1 times 10 to the negative 14th. So you have to divide that number into 1 times 10 to the negative 14th. So that would be divided by 141 times 10 to the negative 4th. That gets you a value here of 709 times 10 to the negative 11th, at which point you take the negative log and get, not surprisingly, a 1015.